Welcome to another video on digital electronics. In this video, we'll be seeing the concept of an encoder. So, encoder is a combinational circuit that will perform basically the reverse operation of a decoder, right? So, it has maximum of 2 raised to n input lines and we have n number of output lines. So, say this is my encoder. It encodes. So, say I have 4 input lines, then I'll have 2 output lines. So this is my y3, y2, y1, y0. This is a1 and a0. So it has maximum how many inputs? The inputs are 2 raised to n and the outputs are n. So here n is 2, which means input 2 raised to 2 is equal to 4. Right, so that's the relation. We'll extend this to a bit higher encoder also. So this encoder is called as 4 to 2 encoder because it has 4 inputs and 2 outputs. It encodes. So say these are the decimal numbers. The decimal equivalent will get coded into its binary equivalent. So how do we make a truth table out of it? Making a truth table is very simple. If you see 4 number of inputs, so these are my inputs y3, y2, y1 and y0. So at any given point only one pin has to be high, and whichever that pin is, equivalent binary will get appeared at the output. So let us consider y1 to be high here, all other are 0. For this my outputs are a1 and a0. Say if y0 is 1, if this pin y0 is 1, then y0's binary equivalent, which is 0 0, will appear at this point. So what will my truth table be? It will be 0 0. Say in the second condition y1 is high and all other are 0, then y1, what is the 1's binary? 0 1 will appear at the output. So it is encoding the decimal equivalent of 0 1 2 and 3 into its binary equivalent. Similarly, third case, say y2 is 1, so it is 1 0, and fourth case y3 is 1, which is 1 1. So this is the truth table of a 4 to 2 encoder. Let us see how to get the equation. How do we implement this? To get the equation, if you apply K-map, then how you will be able to do this? It is very simple, bit logical but simple. Many people get confused into this. The first question is, how many variable K-map you will have? 4 variable, y3, y2, y1 and y0. 4 variable K-maps. How many K-maps? The number of outputs are 2. So 2 K-map, one for A1 and one for A0. How many box K-map? Since it is 4 variables, then I'll have 16 boxes. But then people will say the truth table is not that big to have 16 inputs available. We'll see what to do with that. So this is y3, this is y2, this is y1 and y0. 0 0 0 1 1 1 1 0, 0 0 0 1 1 1 1 0. This is for A1. Similarly, I will make one more here for A0. So this is y3, y2, y1, y0 and this is for A0. 0 0 0 1 1 1 1 0, 0 0 0 1 1 1 1 0. Okay, so let's take A1 first. Let's do for A1 first. So A1, if you see, it is 1 1, it is 1 1 for y3 0, y2 1, y1 0 and y0 0. So y1, y0 are 0 0 here and y3 0 and y2 1 is here. So this should be 1, right? So I will mark this variable box as 1. Similarly, y3 1, y2 0 and y1 0. So last combination, y3 is 1, y2 is 0 and these are all 0 0. So I have one here, this one and this one I have marked. Let us mark this 0 and this 0 also. So 0 is for y3, y2, 0 0, which is the first row, and 0 1 is here. So this is 0. And the second case, both are 0 0 and I have 1 0, which is here. What about the rest of them? Rest of them we don't care, so you have to strictly make all of them as don't care conditions. Please keep this in mind. Many get confused stating that it is a 4 variable but you cannot have a 16 box k map, right? So what about the other combinations, other 12 combinations? We have listed only 4 of them, right? But other 12 combinations all will be don't care. So these are don't care. Let us group them now. How do we group? I have to cover all the ones. So this is 1 here. So maximum 16 is possible, not possible. 8 is possible, yes, possible. So this is one of the combinations of the group to cover this one. And to cover this one, I will have one more combination of 8 group here, right? So how do we write an equation for this? My equation will be, what is remaining same here? I think y2 is remaining same, and here everything is changing, right? So y2 plus, for this it is an SOP, right? But I have only one variable here, so it is sum of the products. Product is only one. Let us do the sum. Second variable, what is remaining constant? These are all changing throughout, so I need not write them. What is remaining common in these two rows? I think y3 is remaining common here, right? 1 1. So y2 plus y3. So your a1 is equal to y2 plus y3. Similarly, if you solve for a0 here, let us do that also quickly. A0 is 1, where you have y3, y2 0 0 and y1 is 1 0. So 0 0 and 1 0. So this is my 1. And the last combination is y1 y0 is 0 0, which is the first column, and y3 y2 is 1 0, which is here. So this is 1. Where do we have 0? You have 0 at 0 0 and 0 1. This is 0. One more 0 is at 0 1 0 0. So 0 1 0 0. The rest of the combinations are don't care, straight away don't care, right? So let's now see what grouping is possible here to cover all the ones. 16 possible? No, because there are 2 zeros, so I cannot do that. Then is this possible? Yes. And for this we know the output is y3, and this is possible. So for this, everything here is changing, so I need not write them. This is y1, so it is y3 plus y1, right? So a0 is y3 plus y1. And if you want to draw a circuit, it is simple. A circuit is very simple here. So I have y3, y2, y1. y3 and y2 into an OR gate will give you a1, and y3, this is y3, y2, y1, right? And y1 and y3 in an OR gate will give you a0. So this is your encoder circuit, which is having 2 OR gates. Similarly, you can do for an extended version, say 4:2, you can do 8:3 also. So 8:3 encoder will be something like this. I will have 8 inputs. y7, y6 up to y0, which are 8 inputs, and 3 outputs, a0, a1 and a2. So you will make the truth table accordingly, like we did here in this case, y3, y2, y1, y0. Similarly, you will make y7, y6, y5 up to y0, and outputs will be 3, a0, a1 and a2, like we did in this case, right? Just to maintain the sequence, it is a2, a1 and a0. So at a given point of time, only one input is going to be 1. So for this to be 1, my output is 0 0 0. All other are 0. Rather, I'll write it properly. y7, y6, y5, y4, y3, y2, y1, y0. So if this is high, all other are 0. My binary is 0, 0, 0. For y1 high, all other 0. My output is 0, 0, 1. Similarly for 0, 0, 1, 0, 0, 0, 0, 0, I will have 0, 1, 0, and so on. You can fill this entire table. For ease of calculations, see here, we did a K-map here. It is simpler to do. It's not the same in the other case. If you want to do calculation right from the truth table, then what is A1 given as? A1 is having 1, 1 here and here. So this 1 reflects y2 and this 1 reflects y3, and that is why your A1 is y2 plus y3. Similarly, your A0, 1 here which reflects y1, and this 1 reflects y3. So hence your output is y3 and y1, right? So to solve here, that's the simplest possible way in which you can write the equation for A2, A1 and A0. So I will fill this table now quickly. Y3 is 1, all other are 0. So this will give me 0, 1, 1. Y4 is 1, all other are 0, which will give me 1, 0, 0. Y5 is 1, all other are 0, which will give me 1, 0, 1. Y6 is 1, all other are 0, which will give me 1, 1, 0. And Y7 is 0, all other are 0, which will give me 1, 1, 1. Now see here, how do you write an equation? Very simple. This is A2. A2 is reflected by these ones. These ones reflect Y4, Y5, Y6 and Y7. So A2 is equal to Y4, Y5, Y6 and Y7. Similarly, A1 and A0, how do we write it? A1 is 1 and 1, which reflects 2 and 3, 2, 3 and last 2, 6 and 7. So I have Y2, Y3, Y6, Y7. Similarly, last is all alternates. So this is 1, 3, 5 and 7. So Y1 plus Y3 plus Y5 plus Y7. That's it, and you just have to implement this using an OR gate. So you can make all those inputs available here. So first one is Y7, Y6, Y5 and Y4. All these go into an OR gate, which makes your A2. I have now everything available but not Y2 and Y3, so you can attach a Y3 here, Y3, Y2, Y2, Y3, and I will take 6 and 7 from here. So use jumpers and take them. Y7 and Y6, these all go to one more OR gate and make it A1. Similarly for A0, I will need one Y1 and then I need Y2 and Y3. So you can take Y2 from here, Y3 from here, and I need one more, which is Y7. So I will take Y7 from here. So you can make it more neatly. Because of space constraint, I am not able to do so. Sorry. So this is your A0. So this is how you implement an encoder, and this one is an 8 to 3 encoder. So I hope the concept is clear. Wherever decimal value is high, it is coding into its equivalent binary value. So Y3 is high here and hence you get a binary value of 0 1 1, which is binary 3. So I'll stop the video here. Thank you for watching.